Well, good evening. Welcome to Space Oddities. Daz, would you like to turn your screen share off? Daz? Where's Daz gone?
Where's Daz?
Oh dear.
Oh, okay. Well, anyway, it's got a slight technical problem. Daz has seemed to have disappeared. But anyway, welcome to Space Oddities. Hope you're all well. Hope you in the UK are keeping warm in the terrible weather that you seem to be having at the moment. And I won't tell you what weather we're having here in Spain. It'll only upset you. So welcome to Space Oddities. When Daz has finished faffing about. Okay. There we are. Okay, we're back. Okay.
I lost connection when you switched on.
Yeah. So if you're here for the first time, you're very welcome to Space Oddities on this Tuesday evening. Got with me this evening some of the usual suspects. Hello, Roger.
Good evening.
Hello, Michael.
Good evening.
And Ian.
Evening all. Oh.
And Lou.
Greetings.
Lou, unfortunately, will have to rush off in a little while to do his teaching, but we hope you can stay with us. Well, you got to stay with us because you're the main feature tonight, Lou. So
I'm the warm-up act. Actually.
You're the warm-up act, yes. And we got Daz. Hi, Daz.
Hello. Sorry about that. When you switched us on, I lost connection all of a sudden, and of course, when it came back on, it had my presentation still there.
Yeah, sorry.
Never mind, I'm here, so yeah, lovely jubbly. We've had quite a bit of snow here, so yeah.
Yep, and we have
got the long trousers on for a change.
Right. Well, on tonight's show, Lou's going to be telling us about a little bit about the history of the universe. Isn't that right, Lou?
Yeah, just a short history. Yes.
Yes, absolutely. And coming up later, Daz is going to be telling us about observing the sun in different wavelengths and what those different wavelengths can tell us. Later on this evening, after the stream finishes at 10 o'clock UK time, we've got the launch of Starship. Yes, it's the 6th test flight of Starship launching out of Boca Chica in Texas. We're bringing you live coverage of the event. And it's going to be pretty exciting because for the first time, Starship is going to be splashing down in daylight. So we should get some nice footage from the Indian Ocean of Starship splashing down. And let's hope this time, again, that SpaceX can catch the booster. That's right. We've got another Falcon Super Heavy booster catch coming up. Just, hopefully to prove that the first time they caught the booster recently wasn't just a fluke. And we will see what happens there. Of course, SpaceX are planning next year to start catching the Starship using the same method. And we'll look forward to that. And we'll bring you everything, of course, as always. Just a little bit of housekeeping before we go on. Don't forget to like and subscribe, please. If you could do that, it really does help us. So if you haven't subscribed to the channel, now's your chance. And why not? And also put a like on the video because it helps us get noticed by the YouTube algorithm. We've been experimenting with artificial intelligence because we haven't got any real intelligence between us, so we thought we'd enlist the aid of some artificial intelligence. We've been experimenting with delivering content to you. Oh, good grief. Bernard's turned up. Hi, Bernard.
Hello, guys. Sorry for my delay.
That's okay.
So we've out of the relegation zone.
Yeah.
He's in Mars orbit.
It's a now magnificent 7.
Indeed. Thank you.
Yeah. If I may continue.
No.
Oh, okay. All right. So we're always looking at new ways to bring you astronomy and space exploration content, as you know. And sometimes we have items on the news that we don't really have time to go to in any depth. So we're going to be creating some videos using AI, and they consist of AI conversations that go a bit more in depth into some things that we've discussed and other things that we haven't discussed. Now, just let me share my screen for a moment because we'd like you to do us a favor. If you look on the Space Oddities channel, which is this, you'll see if you go to videos here, we've got 2 new videos here that I've created one, Daz has created the other. There's one about Europe's SMILE mission, which is a really interesting mission coming up next year to study the Earth's magnetosphere in more depth than ever before. Also, a video about a bizarre new theory that black holes are the source of dark energy. Both of those are AI conversations. And what we would love you to do is, if you've got time, just have a look at them. They are podcasts as such, so it's audio only. But have a listen. Tell us what you think. Do you like it? Would you like to see more of it, less of it? Any feedback that you've got, you can mail it to info@spaceoddities.space, or you can put it on the Facebook group. So if you've got any feedback about those videos, we are experimenting. We're not saying we've got it totally right yet, but we'd love some feedback. So if you could do us a favor, one is 17 minutes and the other one's 10 minutes. So if you could do that, we'd be very grateful, and just give us some feedback. And if you've got any ideas about content that you'd like to see presented in that way, tell us about it. So there we are. I just thought I'd mention that. Don't forget that we have, as usual, the Space Oddities merchandise. We have t-shirts and hoodies available, and they are available by scanning this QR code. And the t-shirts are £25, including UK postage and packing, and the hoodies are £40, including the UK postage and packing. Please add £10 to the total value of your order for foreign orders. So I just thought I'd mention that. Also, yes, if you could remember just to leave a comment on the video after we finished as well, because it will really, really help us. You can support Space Oddities by buying us a coffee by scanning this QR code. We're always really grateful for any donations received via Buy Me a Coffee. You can donate to us directly by clicking the super chat icon underneath the chat window, which is one with a $sign on it. And we are very, very grateful, very appreciative of that, because every last bit of money that is donated goes towards keeping the channel running, because we have bills to pay like anybody else. So there we are. So because Lou has to rush off and do some teaching this evening, we're going to go straight over to Lou now. We'll put him on first this evening, as he said, the warm-up act. So Lou, what's this all about then?
Yes, well, I don't spend much time worrying about all this manned spaceflight nonsense. I don't know what that is, but we are getting such great pictures of the universe coming in for our galaxy, nebulas, clusters, galaxies. But so have you given any thought to what are you actually looking at? Where did this come from? What does it all mean? What is the meaning of life? And we are going to answer all those questions today. Well, some of them, perhaps. So we're going to talk a little bit about the universe and how it developed. Just to quench your thirst. We'll follow it on with some other presentations in the weeks to come. But I wanted to give you just kind of an idea of the history of thought of what is the universe, how big is it, how old is it, how do we know? Okay, 42. Derek says 42, and we'll get to that number in a minute. Yes, he's raining on my parade already. Okay. Can we put the? Let's see. I'm still seeing the 7 of us here as opposed to the. Yeah. There we go. Here we go. Okay. So it turns out that we have no idea what the universe is, but we've been.
Thank you very much for that presentation, Lou.
we have been learning a lot in just a very, very few short years, and I'll just. Of course, we all know our good friend Giordano Bruno, who suggested that the universe was large and there are many stars like the sun, and they have planets around them. And for his efforts, he was burned at the stake. But if we kind of move forward to the 20th century, just 100 years ago, we weren't sure if our galaxy was all there was. Well, we didn't know. Some people thought there was more. Some people thought our galaxy was, in fact, the entire universe, and the universe was infinite and infinitely old and unchanging. Then Edwin Hubble looked at galaxies, and we're going to talk a little bit about his observations, and came up with some numbers that weren't quite right, but he was able to demonstrate that the universe is large and much larger than people thought it was, and perhaps 2 billion years old. Some recalibration of the data in 1955, some of the Cepheid variable data that Henrietta Leavitt had discovered, got the age up to 6 billion years. Looking at distant quasars in the 60s, the universe got a little bit older. In the 1990s, we got distances of maybe 15 billion light years, something like that, 15 billion years, 12 to 20 billion. And then with some of the latest telescopes, HST and the WMAP Wilkinson microwave anisotropy probe, looking at the cosmic microwave background, we kind of settled on 13.7 billion years for the age, and perhaps a observable size of 94 billion light years. So we're still learning, and there's still controversy, and there's still what we'll call a little tension in the data. But let's go back to here we go. Let's go back to 1920, where there was a meeting of the minds of two groups of people, one led by Harlow Shapley, and the other led by Heber Curtis. And this was called the Great Debate. And this was a gathering of scientists to figure out what is, in fact, the scale of the universe. Shapley believed that the Milky Way galaxy was, in fact, all there is, and that these other things that appear perhaps like galaxies were, in fact, nebula inside our own galaxy, and that was it. However, Curtis said, no, it looks like the universe is much bigger than that. And so this was a debate followed by a discussion session to try to figure out what is the answer. How big is the universe? Shapley had some good points. Sadly, based on erroneous ideas and bad data, but he felt that if the Andromeda Galaxy, which is one of our closest neighbors in the local group, were in fact another galaxy, it'd have to be 10 to the 8th light years away, and he said that's ridiculous. He also paid a lot of attention to another astronomer, Van Manen, who said he could see the Pinwheel Galaxy rotating on a period of years. Well, he couldn't, but he claimed he could. And if that were true, then that galaxy should be ripping itself apart and violating the speed of light. At the distances that would have made it a separate galaxy. So that didn't work out. Curtis, however, said, hey, look, there are a number of nova in the Andromeda Nebula, if you will, or galaxy. Why would there be so many more in that nebula than other nebulas? That doesn't make sense. The Andromeda Galaxy must, in fact, be a different galaxy. He observed very large radial velocities, in other words, moving away from us in spiral nebula that suggested they were not gravitationally bound to our Milky Way. And also noticed that many of these nebula had dust lanes that looked like our own galaxy. So, of course, it turned out that Curtis was right, that we live in one galaxy of many others. And I found this picture here, which I just thought was great. This is a picture of the Andromeda Nebula that was published in, let's see, I can't quite read the date here. Hang on a second. It was published in 1888. The photograph labeled as the Andromeda Nebula. And I remember seeing books like this in a dusty old library in the Hale Solar Observatory in Pasadena. I mean, just so exciting to see how far our knowledge has come.
Beautiful. And not bad for 1888, is it?
No,
It's really good.
of course, these are professional pictures, and our audience is going to send in much better pictures. But that's what they could do back then.
Yeah. On glass plates as well.
Yes, sir.
Mm.
Then came Edwin Hubble. And Hubble was observing galaxies from the Hooker reflector, the 100-inch Hooker reflector, which at the time was the largest telescope in the world, on Mount Wilson. And then I found this picture. I thought this was a neat picture. Here's on the left, of course, Albert Einstein observing some of the galaxies that Hubble was observing, and in the middle is Hubble, and on the right, I have no idea who that is. But I just thought that was a neat picture. We're going to talk later about the cosmological constant and how Einstein played a role in all this. And so Hubble observed a number of these galaxies, and he made what's called traditionally called the tuning fork diagram. He said, well, there are different kinds of galaxies. There are ellipticals, give them an E designation. There are spirals with an S0 designation or an SA designation. And then there are barred spirals. And he believed that the ellipticals evolved into spirals. And in fact, of course, today we know it's just the opposite. But he was able to measure distances and velocities of these galaxies. And he came up with this very famous plot. This is the original plot. Of course, I wrote Hubble's 1929 plot on it, but otherwise, this is the original plot of distances and recession velocities of galaxies. The black dots are individual galaxy points. The white dots, if you will, are averages of some of these. And then he kind of drew a line between them, just kind of line of best fit, a couple of interesting lines of best fit. You might notice, if you are very attentive, that there are a few problems with this graph. I don't know if our audience has seen what some of the problems are, but let's go to the next one and I'll show you. The y-axis was mislabeled. It should be a velocity in kilometers per second. The x-axis is labeled correctly, it's distance, but in fact, the 2 times 10 to the 6 parsecs, the 2 megaparsecs, is not 2 megaparsecs. It is, in fact, 16.5 megaparsecs. And based on his data and his assumptions of 2 times 10 to 2 megaparsecs as the most distant galaxies, the universe would only be a little less than 2 billion years old. But he was using a little bit of fuzzy data, a little bad data, and did his best. And this is actually the beginning of our understanding of the formation and evolution of the universe that we know today. So let's talk about how this graph was developed. Since you have nothing better to do than listen to my voice, let's talk about that. The first is that you needed a way to gauge distance to the galaxies. And as our astute panel knows, this is called standard candles. These standard candles were objects, these are stars, in fact, where we know exactly how bright they are. And therefore, if we see how dim they appear, we can tell how far away they are. Just like if you had a light bulb in front of your face, it might be blinding you, but if you held it a mile away, you could barely see it. So this is how that's done. And the first set of standard candles was developed by Henrietta Leavitt, who was at the Harvard College Observatory, and she noticed that a certain classification of stars called Cepheid variables had pulsation rates that aligned with their actual brightness. And so she developed the period luminosity relationship for Cepheid variable stars. These are stars that are actually pulsating in size, getting bigger and smaller. And the rate that they pulsate tells us what their actual brightness is. So all you have to do is view the pulsation rate, and you can know how bright it is. And then how dim it appears tells you how far away it is. When you find Cepheid variables in these galaxies, you can then know how far away the galaxies are. The bigger Cepheid variables oscillate with periods up to, say, 50 days or so, maybe a little more than that. And the smaller Cepheids oscillate with periods of on the order of 3 days. So this was the first set of standard candles that could be used to gauge the distance to galaxies. And here's a plot that Leavitt made in 1912, showing the period luminosity relationship of some of these Cepheids that she'd been observing. Here's a little clearer picture: luminosity on the y-axis, period on the x-axis, and look, it's a very, very straight line. So that if you know the luminosity, rather, if you know the period, you then know the absolute luminosity, and therefore are able to gauge distances to these galaxies that have Cepheids in them. This works pretty well up to a certain distance, because at some point you need standard candles that are brighter than Cepheids. But this worked well enough for the initial figurings of the distances to galaxies. And here's just our old friend, the HR diagram showing the instability strip where Cepheid variables occur, and just in case you were wondering. Okay, so we have distance, but what Hubble plotted was distance versus recession velocity. How fast are these galaxies moving away? And in order to get that, he used the Doppler shift of spectral lines in those galaxies. The more they're moving, the faster they're moving away, the more their spectral lines shift. And there's a very simple little equation that we don't go over in class here to show you what that is and how that relates to the velocity of recession. So here's just an example. If you look down at the very bottom color strip here is a spectrum with a line in it that's pointed to. That's a laboratory reference of gases that are not moving with respect to us at all. You might find a star, going the next one up, that was moving away from us a little bit. A nearby galaxies moving away at a faster velocity, and then distant and very distant galaxies have greater line shifts. And so that's how you determine the velocity of recession, by looking at the Doppler shift in the spectral lines of the galaxy. So with all of that, you put all that together, and more modern day methods have been used to come up with Hubble diagrams with various kinds of standard candles. Some of them are type 1a supernova or type 2 supernova and others. And you can see that they kind of generally follow a line, but there are a number of lines that might fit. The slope of that line is called the Hubble constant. And that's every astronomer knows the Hubble constant. It's just like knowing the speed of light. And the Hubble constant is important because it tells you how old the universe is. No kidding. And you can see on the bottom here that the value of the Hubble constant has varied over time. And as time has gone on and we have better telescopes and better instruments, it kind of settles around 72, but some measurements are more in the 67 region. And we'll talk about that in just a moment. But so why is the Hubble constant important? And here's why. The Hubble constant, as I mentioned, is the slope of that line of velocity versus distance. And so slope is y over x, so velocity over distance. And if I break that down into the units that are used, the velocity is in kilometers per second, and the distance is in megaparsecs. So that's distance per time over distance. Once you convert the kilometers to megaparsecs, so that you're using the same units, you have distance per time over distance, which, if you do a little bit of algebra, is 1 over time. And that time is the age of the universe in seconds. So the Hubble constant is 1 over the age of the universe in seconds, and 1 over the Hubble constant gives you the age of the universe. So the ability to accurately assess the velocity of recession of these galaxies out to very large distances, and the accuracy of the distances with using these standard candles is very important in determining the age of the universe. Now, it turns out that even with our great telescopes and methods today, there's still a bit of a controversy in what this Hubble constant is. What is the value of the Hubble constant? And this is called the Hubble tension. If we look at the cosmic microwave background radiation, it also holds information about the age of the universe and the expansion rate of the universe. And using the CMBR, cosmic microwave background radiation, we get a Hubble constant of about 67.4. If we, on the other hand, look at type 1a supernovas, which are another kind of standard candle, much brighter than Cepheids, and therefore we can see them at much greater distances, we get a Hubble constant of about 73. That doesn't jive with 67. If we look at recent publication of James Webb Space Telescope observations of Cepheid variables and of infrared measurements of carbon stars and tip of red giant branch stars, all of these standard candles, James Webb Space Telescope observations published this August, come up with a figure of 67.4, which compares pretty favorably to the CMBR. Wendy Friedman of the University of Chicago recently did a study with Hubble Space Telescope observations of red giant stars and derived a Hubble constant of about 70 kilometers per second per megaparsec. And the Hubble supernova H0 for equation of state, called the Hubble shoes observations, recently published a number using Cepheid variables as their standard candles of 74. So between 67 kilometers per second per megaparsec and 74 kilometers per second per megaparsec, this is the Hubble tension that has not been resolved quite yet. And so we are still hoping to take more measurements and really pare this down to the actual number, because it is the age of the universe depends on it. And I'm going to stop there today. If there are questions, you can in the chat. I'm glad to try to answer them. And we'll go further than this with the universe and what it's all about in our shows to come. So I hand it back to you, Andy.
Thank you very much, Lou. Thank you very much indeed. If you could just stop sharing your screen.
Yes. How do I do that? Let's see. Oh, I didn't share my screen. I used the.
Oh, okay.
I uploaded my presentation.
That's all right. Give me 1 second, and I'll. There we are. Okay. Hang on, that didn't work. 1 second. Right, there we are. Okay.
Yeah.
So thank you very much for that, Lou. Very, very interesting. Just one question, really. How does the Hubble constant relate to the acceleration of the universe through dark energy?
Well, dark energy is another concept. We look at distant galaxies using primarily type 1a supernovas as standard candles. And we see that not only is the universe expanding today, I must say today, but it appears to be accelerating in its expansion. There are a number of possibilities for why this might be. And just give a quick peek for next week's presentation. It may be that the early universe, which was much more compact and therefore much higher bulk density, had dark matter, right, dominating the expansion rate. As the universe expanded and the bulk density of the universe declined, then the universe was able to expand much faster, and so dark energy then dominates. But I think I'll stop there, and we'll explore a little bit more about this next week.
Great, thank you. All right, guys, I've got to talk amongst yourself for 2 minutes because I've just got to restart my browser. I'll be back in a second. Okay.
Ciao, everyone.
Thanks, Lou. Thanks for that. See you next week.
Lou, that was fantastic. Thank you.
See you next week.
See you, Lou.
Take care.
Bye.
Hello, Bernard. We didn't get a chance to say a proper hello.
No, apologies. I was rather busy, but I managed to join in, so that's great. Always excited to join and to see what's on the session.
Yeah, there's it's I mean, that was fascinating with Lou, and I'll look forward to the rest of the series that he's going to present. But yeah, there's been quite a lot going on. I presume you've been busy with your book. Any news on that?
Well, my book has been published, right? And I finally got, after 2 months, I finally got the printed version of the book. So I got quite excited about it. I got a box a few days ago because my book has been available, but as an ebook, so that doesn't really go down well. So
congratulations! Well
thank
done.
you. It was really exciting to have it tangible, to have something that you can actually.
Oh, you finally got it, have you?
Yes, I finally got it. So
well done.
Thank you.
For those of you that don't know what Bernard is talking about, Bernard wrote a really interesting book about ocean worlds of the solar system. And he's completely revised it in a new edition. And I would, if you're at all interested in the solar system and the moons of the solar system, and these ocean worlds like Europa and Ganymede and all of them, Bernard's book is incredibly well written, and I enjoyed every second of it. And I can't wait to read the new edition. Where can people buy it, Bernard?
Thank you. And every good bookstore, you should be able to order it. But of course, if you go on Amazon, you'll be able to find it. However, I do see that the latest feed that Springer, my publisher, to Amazon, has sent to Amazon has still not updated the availability of the printed version, but it should be available live. But it's still available as an ebook.
Yeah,
right.
Yeah, I'm looking forward to it because I understand it's a pop-up book, and you've got sharks jumping out at you and things like that, and aliens and that. So yeah, look forward to it.
Right. Okay, Josh, I'm going to have to leave you for a couple of minutes because
You'll be updating it all the time, surely, because it's an ongoing thing. This, isn't it? It's very, very recent, very current.
yes, indeed. I'm going to have to leave you for a couple of minutes because reloading my browser hasn't helped. The things are slowing down here, so I'm just going to restart my PC. I'll be back in a couple of minutes. Okay.
Okie doke. So yeah. So anyone got any sort of like origami they can do, or sort of like mime, or anything like? No. So of course we've got later on. We've got the launch of the Starship. This is its 6th test launch. There's quite a lot. There have been a few changes which are going to be very interesting to look at. And one of them is that they've removed quite a few of the re-entry tiles, the shield tiles, because they're looking forward to, I think they were even talking about that possibly on the next launch, which could be before the end of the year, they were saying, of actually attaching catching points to the actual Starship. And they may attempt on the 7th test flight to catch both the Starship and the booster. We were completely stunned in the last flight with them catching the booster. I think everybody wished it would work, but I think deep in their hearts they thought this can't happen first time. And when it did, it was just absolutely amazing. I can remember I was struck for words which my partner says is very rare. Yeah, it was. So we'll be looking forward to that. We will probably be knocking off here about 9:30. Give ourselves a chance to get a coffee, have a bit of a break. Then we'll be coming back at 9:45, I do believe, ready for the launch, which will be 15 minutes after that. So it's exciting times. Yes, yes. Sorry, you were going to say something, Bernard?
Yeah. Why do you do your presentation now while we're waiting for Andy?
No, we'll wait for Andy to come back, and then we'll because we don't want to mess up the schedule. Yeah, so hopefully some of you will be able to join us for the launch. I know it's a school night, but hopefully some of you will be able to join. It's an amazing. Of course, this doesn't happen over 5 minutes. This actually does take about, I think it's about an hour and 20 minutes altogether, with the splashdown of the Starship. So we'll be looking forward to that. And in the meantime, we'll be looking at re-entry. As Andy said before, this is an evening launch. So we may get the booster come back, and it may be getting to twilight, which is going to give us a different perspective on it. But the idea is that when they get to the Starship, comes down into the Indian Ocean, it's going to be daylight there, and hopefully they'll be able to capture some more images, which will be able to give them more data to look at to see how it's actually holding up. And of course, everybody says, "Oh, yeah, but it keeps exploding." Well, if you put very hot metal into water, that's the sort of thing that happens. Things tend to explode. So
It's like
Sandra just said she's off to school so tomorrow.
it's like think about it as if watching a cool science fiction film tonight, right?
Yeah. It is science fiction. This is Thunderbirds' Go stuff. So I know Roger's been watching some Thunderbirds over the week, so he's getting into the spirit. But yeah, this is what this is what science fiction was talking about back in the 50s.
Oh, what we're going to do, as time has now got on a bit, I think I did have some news, but I think I will save that till next week. And I think what we'll do now is go over to Roger for our weekly look at the night sky and the viewers gallery. Do we have a large gallery this week, Roger?
Well, it's almost as large as it was last week.
Really? Oh, great. Okay, well, there you go.
We better plod on. Okay, so we're coming through our latter part of November now for November, and we are at the waning phase for the last quarter through the weekend of the moon, should anyone be able to see the darn thing. This was the last full moon, which was a few days ago, which the Native Americans like to call the beaver moon, because that's when they start getting their dams all sorted out for the winter. So there we go. So as of midnight through these midnight, we are now getting to see Orion coming up quite nicely, and unfortunately Saturn is getting towards the southwest setting, but we do have other planets available, notably Jupiter and Mars, which are still wonderfully high, and will be quite a good sight to see over the next month or two. So be aware of that. Although we do have the moon passing through the areas, so photo opportunities be available. So we've also got Mercury following alongside Venus shortly before sunset. So they are still quite low to the horizon, but opportunities for seeing a Venus after sunset are getting quite good now, and it does present itself as a very nice evening star. So have a look out for that should you have the opportunity, and that will be just past the southern horizon when it does get dark. Schunnessen Atlas is still about, but it is rapidly decreasing in the magnitude scales. It's currently 8.3, but it would be magnitude 10 by about the middle of December. So I think we're almost saying farewell to that now, and we're looking forward to the next opportunity of something which will replace it, although it was no comet of the century by any means. And here we've got a comparison of some galaxies taken by the James Webb and the Hubble. And it just gives you an idea of how much clarity the two different scopes are providing with the same objects. And it gives you some interesting interactions here and how they are influenced under the different wavelengths of light. And as you can see, it's almost unbelievable how much the intricacies of interacting galaxies there are to be seen in this with this object. So all well and good. And this is a combination of the two images put together to give you a really fantastic looking, interesting sight to behold that we would never normally have been able to have seen otherwise, unfortunately. But very interesting indeed. And there's some interesting observations from Hubble and the Webb of a circumstellar disk around Vega. And as you can see on the right hand side, you can see some various densities of light around where the sun has been, the star has been blocked out, to give you those comparisons of how they compare.
If you just go back to that a second, Rog.
Yes.
There have been some very interesting questions asked about Vega recently, because here we're looking at a young star that is only a few million years old. Vega, of course, is that brilliant blue-white star that's right over your head in midsummer. Can't miss it. And the question is, there have been no exoplanets detected around Vega at all. So the question is, why not? If we assume that planetary systems arise around all stars, which is a fair assumption, a star as young as Vega should, at least with this protoplanetary disk, which is what it is, have started generating planets. Now, if you look at some of the images from the ALMA radio telescope in Chile, which has taken some fantastic images of protoplanetary disks, you can see dark lanes within the disks, like rings, which is where young planets are clearing their orbits of dust. We don't see anything like that around Vega. As you can see, we don't see anything like that around Vega. So it doesn't seem as if there are any planets forming around Vega at all, which may make it very strange, because every single protoplanetary disk that we've looked at has got young planets in it. So that's a big question about Vega. So we'll have to wait and see what happens about that. But at the moment, it looks as if Vega's quite an unusual star, because it doesn't have these dark lanes in its protoplanetary disk, which, given its age, it should have. So there we are. I just thought I'd mention that.
Thank you, Andy. Right. Okay. So we've got an interesting collection of images from our gallery. So I will no doubt we can all make comments and say how wonderful these are. So we've got Ian with a moon halo through some clouds.
Just
Very impressionistic.
yeah.
Yeah, very nice.
Yes.
Thanks.
Of course, clouds seem to be the dominant thing this year, so we're all quite in the same kettle as Ian's picture there. So we've got Jerry with an elephant's trunk nebula with his usual setup, and he's got 35-minute exposures with his equipment. And here we've got the elephant's trunk.
Oh, very nice, Jerry. Look at that.
Yeah, you can sort of see the definition of it there.
Yeah, it's like fantastic detail in that. Wow. What was the integration on that?
That was 30 times 5 minutes.
Right. Gosh.
So 2.5 hours, basically.
Yeah. Very nice, Jerry.
Well done, Jerry. Right. Okay, so we've got a few from Rachel and Johnny.
Oh,
Of course, Rachel we haven't seen for a while, but there's a collection of 4 pictures here. One is a Wolf Rain at 134. We've then got the Wizard. We've got the Cygnus Wall and the Tulip Nebula. So they're all pretty much done with 1 or 2 of the telescopes here, and all mounted on the same equipment. But no doubt we will guess how these are. So this is the Wolf Raynup star here, and you can sort of see the what I'm getting is a pressure bow there over to the right of the star there. So that looks
Wow,
quite
very
interesting.
nice,
Yeah.
Johnny.
Very
nice indeed. Look at that.
Yeah, it's very good.
Super.
And her next one is the Tulip Nebula.
I can see why,
Yes.
That's beautiful.
isn't it?
Mm.
Isn't that lovely?
And she doesn't use. She only uses Photoshop, I believe. Doesn't use Pixinte at all. So
No, I think she uses Photoshop,
yeah.
which is
So
beautiful.
all strengths to her. And here is the Wizard.
Ah,
That's
wow.
She does like the Wizard.
Yeah. Who
The
wouldn't?
Wizard. Absolutely. And their 4th image is the Cygnus Wall.
oh, that's nice.
Oh, that is nice, isn't it?
Mm.
Yeah, we usually see it about 180 degrees round of that, but that's how she's presenting it.
Well done.
Well done, you two.
Yeah.
Sweet.
So
Very nice.
Rachel tells Johnny where to go and point the telescope, and she does the processing. That sounds like a good partnership.
Yeah, it does, doesn't it?
Right. Okay. So we've got another interesting starscape with the Delabole Village Hall at St John's Church here. So here's what he's done with a Canon 600D Samyang 14mm lens, and the sky was done with a slightly longer lens as well. So this is the combination of the results. Ooh.
Oh, look at that. Wow.
Yes.
Very atmospheric.
Yes. All you want now is the werewolf.
I was going to say, you expect something to come up out of that.
An American werewolf in Cornwall.
Lovely. Lovely.
Don't go out to the moors. Okay, now this is one of mine. This is just a general one with my little mirrorless camera of a sunset with Venus in the night sky. And we had quite a spectacular sunset on that night or evening.
Beautiful.
It's about a third of the way from the right-hand side, about halfway up, if you can't spot Venus.
I see it.
See it.
Yep.
Mm.
Where's Wally? So it is visible pretty much for most people. You just have to make sure you've got just a southwesterly view of the skies to get a glimpse of that big bright shiny Venus in the sky.
So what are the 2 dots at bottom right? Are they hot air balloons?
That's probably just a bit of muck on the sensor, I think.
Yeah. Lovely, Roger.
Okay, so I've been trying to get some decent pictures of Saturn, and this one I managed to get 4 of the moons as well. So I got Titan, Dione, Tethys, and Enceladus, and this was on the 14th of November.
Wow.
Yeah.
You did get them.
I did get them, yeah. I did do a separate exposure for the moons because they're so faint compared to the main Saturn, so I had to give it a boost and then just plonk into the position where where Saturn was really overexposed to put them together. So yeah.
So which moon is where?
Right. Okay, let me go back. So it's Titan, Dione, Tethys, then it's Saturn, then it's Enceladus to the right.
Oh, right.
Yeah, Titan's going to be the furthest away, of course.
Yeah,
Yes.
and the biggest,
And,
Yeah.
and yeah, it's quite a way away, isn't it?
isn't it?
Mm.
Yeah.
But it is always quite easy to spot, even in the eyepiece of a telescope, to see it. So
Because you quite often see artists' impressions of Saturn from Titan, and a lot
And
of
it's
them they got Saturn far too big in the sky.
yeah.
Yeah.
I mean, even if Saturn was in the place of our moon, it still wouldn't dominate the sky really, like the artist would.
No, that's right. That's right.
And the worst artists will actually show you the rings of Saturn, at an angle, which is not possible for the Titan.
No, that's right. That's right.
Unfortunately, with the angle of Saturn at the moment, the rings are fairly dim, so we're not getting as much reflectivity of the ice crystals as we would normally get with the narrowing gaps. Here's just a closer view of the of it, just to show you how dim the rings are really at the moment.
Yeah.
So it's not exactly awesome, but it is if you've never seen it before. Okay, so I've now got a couple of images of Jupiter with a Europa transit. Okay, so the one on the left shows you the shadow, and the one on the right shows you the moon escaping the Jupiter, so you can actually see it. I believe that it was roughly to the left of the red spot, but I obviously haven't picked it up from the first picture, but there we go. Okay, so that's what we have for the gallery this week.
Thank
and
you.
Well done for those contributions, especially from Johnny and Rachel.
Yes, nice to see them. Nice to see some of their images again.
We need them back.
We do indeed. So, if you would like to send us your images, viewers, as ever, put them in an email, attach them to an email, 1 image per email, please, just to make life simple, and address your email to gallery@spaceoddities.space. And that's it. And as we always say, you don't have to use expensive, sophisticated equipment. Any image of the universe, whether it's distant galaxies or even just a sunset shot, like Roger's one of Venus. Anything you would like to share, then please send them to us, and we will include them in our weekly gallery. If you would like to contact us for any reason, for anything really, you can email us at info@spaceoddities.space. That's info@spaceoddities.space. So there we are. How many of a time? Just a reminder, viewers, that coming up at 9:45 UK time, so I have to do the time zone bit. 9:45 UK time, we'll be bringing you live coverage of the 6th SpaceX Starship test flight, which we're all looking forward to see whether SpaceX can do it again with the modifications they've made to the Starship and the booster since Flight 5 a few weeks ago. It'll be interesting to see what happens. They've made many modifications based on the data they got from Flight 5. So it will be really interesting. Also, as I said earlier, it will be the first daytime splashdown of Starship in the Indian Ocean. So we should get some nice shots. Did any of you see those lovely shots from that SpaceX released, taken from the camera underwater, under the Indian Ocean?
Oh yeah, I did see them. Yeah.
Yeah. There was a lovely bit of video before the camera died of it being underwater in the Indian Ocean after the last splashdown. So it looks to be really, really good. The big question is, of course, can SpaceX catch the booster again? I think the whole world was amazed when they caught the booster last time on the first attempt with the Mechazilla tower with the chopstick arms. You'd be amazed the number of people that have actually said to me, "Oh, I saw that rocket thing being caught." So it did generate a lot of interest from people who are not normally interested in that sort of thing, because it was such an epic sight to see a booster the size of a skyscraper being caught in midair by 2 mechanical arms. And, you know, whether you love Elon Musk or hate him, you cannot deny his genius in coming up with ideas like this, because he actually came up with the idea of those mechanical arms, the so-called chopsticks, while he was having a Chinese meal, because they were thinking of ways of landing the booster. They didn't want to put legs on the booster because they weigh too much, which would cut down the fuel capacity. And Elon Musk just suddenly came up with well, why don't we try and catch it in midair? Everybody thought he was completely mad, of course, but he was proved to be right. So was it a fluke last time? We know now that there was a problem with the booster just before the booster was caught by those mechanical arms, that the engines weren't developing enough thrust, but luckily it all worked out. They've now tweaked the parameters of the engine, so they won't have that problem again, hopefully. So join us at 9:45 UK time, where we'll talk you through the mission. And we're all really looking forward to it. Exciting times. SpaceX do intend to mount another test flight before Christmas. So let's see how this one goes. Okay, well, what we're going to do now is to wrap things up here for the evening. We're going to have a break and get our studio ready for the live coverage of that mission. So we'd like to thank everybody for watching this evening. Sorry we had a few technical glitches this evening, but such is life. And we hope to see you back at 9:45 UK time for the 6th test flight of Starship. So from everybody here at Space Oddities, if we don't see you back later, have a fantastic week. Thank you for watching. Don't forget to like and subscribe. And don't forget you can donate to Space Oddities by using that super chat dollar icon under the chat. And yet again, I will say all money received goes towards keeping the channel running. It's not going to make us millionaires, maybe one day. So we'll see. Okay, well, thank you all for being here. So from all of us, from myself, from Roger, from Michael, from Ian, from Daz, from Bernard, who came in late, but he had a note from his mother, so that was okay. And lovely to see you back, Bernard. And we will see you all same time next week at 8 p.m. UK time on Space Oddities. But don't forget, in about 20 minutes, we'll be going live for the launch of Starship. So thank you for watching and good evening.